Okay, in this video we are looking at units of concentration. Concentration, of course, is a measure of an amount per volume or an amount of solute per amount of solvent. There are several ways to express concentration, and we're going to look at a few of them in this video. A couple of them are listed over here. So we have molarity, which hopefully you're aware of, is moles of solute over liters of solution. So that being the big idea here is that this is the total solution. So this would be solute plus solvent. Molality, and we'll talk more about molality in a few minutes, is a measure of moles of solute over mass of solvent. So it doesn't include solution, but just the solvent by itself. Another common way to measure concentration is with percentage of solution. The percentage can be either in percent volume ratio, percent mass to volume, or percent mass to mass. So we're going to look at some examples of how this works for different concentration units. Alright, so the first one we're going to look at is with molarity. Molarity is moles of solute per liters of solution. So it's important there to know how much solute you have, converting grams to moles, or you can start with the moles that you have, and then you also need to know the total volume of the solution. Now, although molarity is fairly common in terms of use as a concentration unit, it does have some things that affect it negatively, such as temperature. Temperature can affect volume changes. If I have to heat up a solution to dissolve my solute, that is going to possibly change the volume of liquid that I have. Alright. The other thing to worry about with molarity is sometimes it makes making the solution very difficult because worrying about the temperature, worrying about the phase of your solute and your solvent, worrying about the interactions being affected by temperature can all change the solubility. Alright. The other thing to keep in mind is the volume of the solution is not always the same as the volume of the solvent. So even if I put 5 grams of some solute and mix it with a liter of water, it doesn't mean my solution is a liter. My solution could actually be greater than that because of the added solute. So you have to keep that in mind. Alright, you've worked with molarity before, but we're going to do one example of how to calculate molarity based on our solute and our solvent. Alright, so we're going to look at the molarity of glucose in a 12-ounce can of Coke. So glucose has the formula C6H12O6, and this is our molar mass, 180 grams per mole. Alright, so if we look at what we have a 12-ounce can of Coke. That'll help us get our volume for the whole solution. And we have 39 grams of glucose, that's our solute, in the solution. So let's start with the 39 grams. We need to convert that to moles in order for the molarity to be calculated. Alright, so our 39 grams to convert to moles, we're going to multiply by the reciprocal of the molar mass, or if you prefer, we're going to divide by the molar mass. This will then give me how many moles we have. Alright, so let's look at our calculator. We have 39 divided by 180. 0.217, and this would be our moles. Alright, then we want to look at total liters of the solution. So we have 12 ounces of our solution, which is the same as 355 mils. Okay, so we just have to convert this into liters. So 1,000 mils on the bottom, 1 liter on the top. We have 0.355 liters then of our solution. So our molarity, capital M, is going to be our moles, 0.217 moles, divided by our liters, 0.355 liters. Okay. So we already have our moles in there. We're going to divide by 0.355, 0.61 for our molarity. Alright, so this helps us to determine the concentration of our solute and solvent. That is one type of concentration unit. The next thing we want to look at are our percent solutions. For our percent solutions, there are 3 types. Alright, we can have percent mass to mass, percent mass to volume, or percent volume to volume. So let's look at what this means. If we have percent mass to mass, it means we're comparing the mass of the solute to the mass of the solution. So a 10% mass to mass KCl solution means that we have 10 grams of our solute KCl per 100 grams of the solution to make it 10%. Likewise, a mass to volume solution means we have grams of the solute and we have volume of the solution. So a 5% glucose solution is 5 grams per 100 mils of the solution. And then a volume to volume means we have milliliters of our solute and milliliters of our solution. So the bottom of the ratio is always to the solution, and the top refers to our solute. So a 12% ethanol solution would be 12 milliliters of ethanol per 100 mils of solution. So we can turn these into conversion factors by putting our grams of solute over solution or flipping it around to have solution on the top over the solute, depending on what we need for our question. Alright, so let's look at the question that we have. Chemical analysis shows that 25 mils of a solution contains 2 grams of glucose. Calculate the concentration in percent of glucose. Alright, so we can do this in terms of grams per volume because that's what we're given. So if we have 2 grams divided by our 25 milliliters, we can calculate what that ratio would be. Alright, so that's 0.08 for our ratio. If we then want to turn that into a percentage, we multiply by 100, and that would give us an 8%, and this would be mass to volume ratio. Alright, let's look at the second question. Calculate the percent mass of an NaCl solution if 5 grams of NaCl is dissolved in 200 grams of water. So this is a mass to mass relationship. So we're going to put the mass of the solute on the top, and then the mass of our solution goes on the bottom. So remember, mass of solution does not mean mass of solvent. We have 200 grams of solvent, we have 5 grams of solute, so the bottom we're going to put them together because we need the total solution. Alright, so let's look at our ratio first. So we're going to have 5 divided by 205 for our total. So 0.024, we'll call that another 4. Alright, and then to get percentage we multiply by 100. So 2.4%. Alright, let's look at using our percentage as a conversion factor. How many mils of a 1.2% mass to volume solution will contain 0.15 grams of KCl? Alright, so we're going to start with the 0.15. So anytime we're doing these types of word problems for calculations, we want to start with what we have or what we want. In this case, we want the 0.15 grams, and we just need to know how much of the solution is going to have that. So we're going to use our conversion factor, because we're converting between the grams that we want and the volume that we need using our percentage as a conversion factor. So our 1.2% means I have 1.2 grams of KCl per 100 milliliters of solution. Alright, so I'm going to set it up as a conversion factor so that my grams are going to cancel. So now I have 0.15 divided by 1.2 and then times 100. So 12.5 milliliters. Okay, another way you could do it is go across the top. 0.15 times 100 divided by 1.2. Okay, you get the same thing. So we have 12.5 mils that could contain our appropriate amount of grams. Let's look at the second one. How many grams of sodium chloride are needed to prepare 125 milliliters of a 12% mass to volume NaCl solution? Alright, so again we're going to use our conversion factor. We want 125 mils, so we're going to start with that. And we're going to use our conversion factor to go back to grams. So for our conversion factor, we have a 12% mass to volume solution. So that means I have 12 grams of NaCl per 100 milliliters of solution. Alright, so our milliliters are going to cancel out, and we're going to be left with our grams. Alright, so we have 125 times our 12 divided by 100. So this would be 15 grams of the NaCl. Alright, then the last one. How many grams of sodium hydroxide are needed to prepare 45 mils of an 11.5% mass to volume sodium hydroxide solution? So this looks exactly the same as the last one. Okay, we want 45 mils, and we're going to use our conversion factor. We have 11 grams of NaOH per 100 mils of solution. Alright, and our milliliters will cancel out, and we'll be left with our grams. Okay, 45 times 11 divided by 100. So 4.95 grams. Alright, so we can always use our percent solutions as conversion factors to help us out. Alright, the third type of solution concentration is molality. Molality is similar to molarity. We have moles of solute on the top of the ratio, but then on the bottom we have mass of solvent instead of solution. And it's not measuring volume, it's still looking at mass. So this can be a more accurate way to measure concentration than molarity because it is not affected by temperature, because we're not looking at volume changes due to temperature. and it only depends on the mass of the solvent and the moles of the solute. So we can know both of those things going in. So neither one of those changes because of mixing with the other. All right. One thing to remember about molality, because the density of water is approximately 1 gram per mil for room temperature, 1 liter of water is approximately 1 kilogram of water. So molarity and molality for very dilute solutions are usually the same, or very close to the same, especially at room temperature. Alright, so we're going to look at a calculation with molality. 18 grams of calcium nitrate dissolved in 555 mils of water at 25 degrees Celsius. And the density of water at our room temperature is 1 gram per mil. What is the molality of the solution? Alright, so remember we need moles of solute over kilograms of solvent. So we're going to start with the solute. I have 18 grams. I need to convert the grams into moles because the top part of my ratio is moles. So if we look at calculating our molar mass for calcium nitrate, we have 40 for calcium, we have 14 for nitrogen, we have 16 for oxygen. So we can calculate what our molar mass would be. Let's do the oxygens first since we have the most of those. Oops. So we have 16, and then 160. 16 times 6. Okay, so 96 for the oxygen, plus 14 plus 14, because we have 2 of the nitrogens, plus our 40. 164. Alright, so this is 164 grams per mole. So we're going to use that as our conversion factor to convert grams to moles. So 1 mole over 164 grams. And this can give us the moles we have in our solution. Alright, so we have our 18 divided by 164, 0.1, well, we'll call it 0.1098 for now. We'll cut the sig figs down later. Alright, so those are our moles. Second thing we need to look at is our kilograms of solvent. So right now we have volume. We need to convert that into grams using our density, and then we can convert it to kilograms. So 555 milliliters. We have a density of 1 gram per mil. So that's still going to be 555 grams for our water. And then we need to turn that into kilograms. Alright, so there's our conversion factor. So we have 0.555 kilograms of our water. And remember, solvent is what we need for this. So our molality, lowercase, usually italicized little m, is our 0.1098 moles over our 0.555 kilograms. Alright, so we have it looks to be about 0.20 molal. Alright, so that would be the molality of our solution. The last concentration units we're going to look at are mole fraction. And mole fraction you're hopefully familiar with from looking at partial pressures and Dalton's laws. But if not, mole fraction is represented by moles of solute over total moles. So adding up the moles of the solute plus all the moles in the solvent. And this can be used if you only have one solute. This can be used if you have multiple solutes. You just have to add all the total up for the bottom part. And mole fraction is represented by the large X, and normally the little subscript next to it tells you what you're doing the mole fraction of. So you can do mole fraction of solute or solvent. And then mole percentage, or mole percent, is really just mole fraction times 100, so turning it into a percentage. Alright, so we'll do one example with our mole fraction. We have a sample of alcohol that is 98 grams of ethanol and 303 grams of water. What are the mole fractions of each? Alright, so we have grams of both our solute and our solvent, and we need to turn those into moles. So let's do the mole fraction of ethanol first. Alright, so large X, ethanol. We need to have our moles on the top. So I'm going to have 98 grams of my ethanol. I need to convert that into moles by using the molar mass again. So we can calculate molar mass of ethanol. Carbon is 12, hydrogen's 1, oxygen 16, hydrogen's 1. So if we add this up, we have 2 12s is 24, 5 1s is 29, the other one is 30, plus oxygen gives us 46. So 46 grams per mole for our ethanol. So we're going to put that there. This should give us our total moles for ethanol on the top. And then we need to look at what goes on the bottom. So for the bottom, we need to add all of our moles together. So we need our moles of ethanol, so same thing that we have on the top, plus we need our moles of water. So we have 303 grams, so we're going to do the same thing we did with the ethanol. We're going to turn our grams into moles. Molar mass of water is 18 grams. Alright, so this will give us our mole fraction. So we're going to simplify all of this. So first we're going to do our ethanol, so 98 divided by 46 means we have just over 2.13 of our moles. Alright, and then let's do the bottom. So this first part's the same. Let's look at the second part. 303 divided by 18, 16.83. And remember, we need to add that to the 2.13 we had from the ethanol. So the bottom part should be about 18.96 moles for our total moles of the solution. So then we just have to do our math. Alright, so our mole fraction of ethanol then is going to be our 2.13 divided by 18.96. So we have 0.11. So that would be our mole fraction of ethanol. And we can turn that into a percentage by multiplying by 100. So that would be an 11% ethanol solution. Now for our mole fraction of the water, we have the same type of calculation, but we want to put water on the top. Now we already calculated we have 16.83 moles of water. So we're going to put that on top. And we've already calculated that the total is 18.96 moles for everything. So we'll put that on the bottom. And we can calculate our mole fraction of the water. So 16.83 divided by 18.96, and we have 0.89 for our mole fraction. And as a percentage, this would be 89%. Now hopefully you'll notice something. about our solution, since we only have ethanol and water in our solution, our percentages have to add up to 100. So we have 11% ethanol, 89% water, so that gives me the 100%. So even before I calculated the percentage of water, if I only know the percentage of ethanol, I can still determine the percentage of water without doing this math by just subtracting from 100. Alright, so those are the types of concentration units and calculations you'll be responsible for. We're going to talk about using these for the next part of the class, colligative properties, and doing the calculations with those formulas. So please work on doing your calculations for molarity, molality, percent solutions, and mole fractions so you'll be prepared.